In this video, I'm going to introduce the sailboat case that forms the backbone of Lederman's argument. We're going to see what the case involves. We're going to motivate the premises of Lederman's argument. First, let's see what the case actually says. We're imagining that Roman and Columba are these two characters and they're involved in a game show. Each of them has a button on the console in front of them. They can see each other, they can see each other's faces, so they can see in particular what they're looking at, and they can both see that there's an area in front of them between their consoles. On this area in front of them, the host is going to place a sailboat. In fact, there are going to be two sailboats placed. So first of all, they're going to place what you might call a test sailboat. And we'll say that Roman and Columba know in advance that the mast of this sailboat, the test one, is going to be 100 centimeters. So this test boat will be placed down, the 100 centimeter boat, and they'll both be able to see each other and to see the boat. And so they'll know that they're looking at it. Then we'll imagine the test boat is taken away and it's replaced with a different one. And their task is to press the button in front of them if they think that the replacement boat, the boat that comes second after the test boat, has a mast higher than the first one. Putting it differently, since the mast of the first one was 100 centimeters, they should push the console button if the second boat has a mast taller than 100 centimeters. There is, however, a catch. To win the money for the game show, they have to both press. So if they both press, and it is indeed true that the mast of the second is taller than the mast of the first, then they both get $1,000. However, if only one of them presses, even if that one is right, they're both going to lose money, we'll say. So they'll both lose $100 if one of them fails to press when the second mast is taller than the first. We'll also say, just to round out the case, that they lose money, the same amount of money, if they both press erroneously when the mast is shorter than the test mast. That's the setup of the game. So we can imagine that they're looking at each other. The first boat is lowered into the area in front of them. They take note of its height, because remember that's what they have to try and compare it to. The test is then taken away. The second boat, whose height they basically have to guess, is replaced. And we'll imagine that this boat is 300 centimeters tall. So the mast of the second boat is 3 times as tall as the mast of the first boat. The idea here being that if the mast of the second is 3 times tall, then it should be clear to both of them that the second one is taller. That's the setup of the case. They're trying to win money. They win money just in case they both correctly press the console button when the second mast is higher than the first. But of course they have an incentive to coordinate here. And in particular, as we'll return to in the final section, they should only press the button if they know the other person is going to do it too. So even if I know, for instance, that the second mast is taller than the first, if I'm unsure about whether the other contestant is also going to push, then I should refrain from pushing. Because if I push the button and the other doesn't, even if I'm right, even if the second mast is taller, then I'm still going to lose money. So they'll only press the button if they're both sure that the other person is going to press the button. Let's now think about this case. It seems in the way that we set up the case, where the mast is 300 centimeters tall, clearly taller than the first one, it looks like both players should press the button. It looks like they're going to coordinate. They will both be satisfied that the other person is going to press the button, and so they will press the button themselves. If that's right, then that seems good reason to think that in this case, it's public information that the second mast is taller than 100 centimeters. Why? Well, because they know the height of the first mast, they know that's 100 centimeters, and because the second one is so much taller, it looks like it should be obvious to everyone in the case that it's taller than the first one. So putting those two things together, you get that it's public information that the second mast is taller than 100 centimeters. But remember, we're assuming in the background a thesis about what it is for information to be public. And we're going to assume that Roman and Columba are ideal reasoners. That being so, since they're ideal reasoners, the thesis of ideal common knowledge says that since it's public that the mast is greater than 100 centimeters tall, it should be common knowledge that the mast is greater than 100 centimeters tall. This is going to be the assumption that we submit to a reductio in the argument. And I'm going to call this assumption public when we need a name for it. There are a few other premises about the case, though, that we'll need to get the argument going. One assumption that we'll need is that the mast of the second boat does appear to be some height or other. We'll stipulate that it in fact looks to Roman that the second mast is 300 centimeters tall. So it has to look some height to him. Let's just arbitrarily pick 300 centimeters. Once you see the argument, you'll see why it doesn't really matter so much exactly what height we say. Another assumption that we're going to draw on is that it looks like in this case, we can even, and if it's not clear, we can just stipulate it, that it's public information that appearances aren't going to be deceiving. It's a perfectly normal case. We'll imagine that they both know of themselves and of each other, that they're normal perceivers. So it looks like that it should be public information that if the mast looks to be a particular height, then for all they know, it is that height. Now just be careful about what's being said here. I'm not saying that if it looks to be that height, they know it's that height. Rather, if it looks to be that height to one of them, then it could be that height. Put it another way, it's not going to be the case that the mast looks to be some height, but they know that it's not that height. So that would be a case of an illusion, if the mast appeared to them to be some height, and yet they were able to know that the appearance was misleading. So we're stipulating that they're not in a case like this. If something appears to them to be a certain height, then it could very well, for all they know, be that height. This is public information. In particular, it's public that this is true of both of them. It's true of both of them that if the mast looks to be a particular height, then for all they know, it's that height. And we're going to call this premise no known illusion. You'll see on the handout that I've broken it up into two, each corresponding to each person, but that's the general idea of the premise. Next is the really crucial assumption that is basically going to do all the work in the argument. This assumption says that while they may know some things about each other, they don't know exactly how things look to the other person. They can assume that they're roughly similar. So Roman can think, if the mast looks a particular height to me, then it should look something like that height to Columba. And likewise, Columba should think, well, if the mast looks, for instance, 300 centimeters tall to me, it should be something in the ballpark of that for the other person. However, while it should be in the ballpark, it does seem like they can't rule out that their perceptions might be slightly different. So while Roman should think it would look in the ballpark to Columba, it could look slightly shorter. For instance, it might look 3 centimeters shorter. That number may or may not be a plausibly big one. Again, as you'll see, it doesn't really matter what number we'll choose. So I'll just say it's clear to Roman that while the mast looks 300 centimeters to him, it could well look slightly shorter than that to Columba. In particular, it could be that while the mast looks 300 centimeters to him, it actually looks 3 centimeters less than that to Columba, so 297 centimeters. And again, the situation is symmetric. So again, it's public and therefore common knowledge that if the tree looks to be a certain height to Columba, then for all she knows, it could well look a little bit shorter to Roman. Namely, it could look 3 centimeters shorter to Roman. Again, this idea seems pretty plausible when you think about it in the case. So they know that they're looking at the same mast, they know they're roughly the same distance away from it, so they should know that things look roughly the same to both of them. But it's not to think they only know that things look roughly the same. It doesn't look like Columba could say, oh, I know for a fact that however things appear to me, they appear to be exactly the same to Roman. In particular, if the tree looks a particular height to me, it looks exactly to be the same height to Roman. That doesn't look like something Columba can say. It looks like that would be going beyond what she has evidence for. If that's right, then for all she knows, appearances could be a little bit different for Roman, and they could be different in either direction. It could be that it looks a little taller, it could be it looks a little shorter. We're going to focus on that it looks a little shorter because that's what's going to work for our argument. But the basic idea here is that their minds are not totally open to each other. Regardless of what kind of information they have about their own perceptions, they don't know for a fact exactly how their own perceptions line up with the other person's perceptions. And moreover, it's plausible to think that that fact, that their minds are not completely open to each other, that itself is public information. So this is the thesis we're going to call interpersonal ignorance. And as I said, this is the claim that's really going to do the heavy lifting in the argument. The last assumption I'm going to make is that closure holds. We've stipulated that both people are ideally rational. So it's going to be the case that if they know something, some proposition P, and they know if P then Q, then they know Q. Or more generally, if they mutually know to some degree some proposition, P, and they mutually know if P then Q to that same level, then they mutually know to that same level the conclusion of the argument. Liederman has a slightly more complicated version of closure that's stated in terms of pertinent consequences and things like this. We're just going to work with a straightforward closure case, and we're going to ignore the kind of putative counterexamples to closure that we saw at the very beginning of the semester, because as you'll see, the kind of case that we're thinking about is very different from what goes on in skeptical arguments. So these are all of our assumptions about the case. We now have a bunch of premises. We've gone through them, and we've seen that each of them seems to be well motivated in the case, or at least they all seem to be well motivated, given the assumption that because they're ideal reasoners, if some information is public, then it's commonly known. What Liederman is now going to show is actually, on the assumption that public information is common knowledge, these theses are actually incompatible with each other, because you can derive a contradiction.